Um, yeah, so today we're going to be doing number 44 from Giancoli. I've got Luna on my lap. But yeah, go ahead and read number 44. We're doing a physics problem here.
The best rebounders in basketball have a vertical leap, that is, the vertical movement of a fixed point on their body, of about 120 centimeters. What is their initial launch speed off the ground? And B, how long are they in the air?
So this is pretty relevant because the NBA Finals were last night. So what are we looking for? What are we solving for in A?
So in A, we are looking for the initial velocity.
Right. What is the final velocity going to be at the top of their jump?
At the top, it's the final point before they start falling. So we know that'll be 0.
Right. At the top, they're momentarily paused. So we have VF equals 0. What is the acceleration?
The force of gravity is involved, and since it is working against something as it's rising up, it'd be negative 9.8 meters per second squared.
Right. Gravity's always down. Finally, do we have delta X or delta Y, depending how you want to see it?
So the delta X is 120 centimeters, and I forget Y.
So we don't write it down as 1.2 centimeters. We would write it down as 1.2 meters. So 120 centimeters, if you were to do that times, there's 1 meter per 100 centimeters. So we divide it by 100 to cancel out the centimeters and replace it with meters.
Gotcha.
So that's converting. And that comes from the list of prefixes. Cent means 1/100. So we have all this information, and in part A, we want to solve for V initial. We have our 3 kinematic equations: V final equals V initial plus AT, delta X equals V naught T plus 1/2 AT squared, and V final squared equals V initial squared plus 2A delta X. Which one of these do you want to use?
We should use equation number 3.
Right, how come?
So for part B, we're solving for time. So we don't have time to plug in just yet. And for the first part of the problem, we're looking for V initial. And for equation 3, we have everything but V initial. So I think it would be the easiest to solve for what's missing if we plug everything into equation 3.
Perfect. I'm going to start plugging things in. You can go ahead and do it at the same time. So we have 0 squared for V final equals, we don't know V initial, plus 2 times negative 9.8. And then delta X we know is 1.2 because it's going up 1.2 meters. Perfect. I'm going to get out my calculator and begin simplifying this. Let me know what you get for your answer.
So my V initial is 23.52.
Pretty good. But I think you forgot one step in the algebra. There's one final step. You can look at my screen here and try and tell me what it is.
It's squared.
Right. How do we get rid of that square?
Okay. Do we do the square root?
Yep, perfect. Take the square root of both sides. And technically that's going to give you a plus or minus answer, but we're just going to take the positive answer because we know that's initially going up, not down. So
when I did the square root, I got 4.85.
Perfect. And what's the unit?
4.85 centimeters?
It's a velocity. What are the units of velocity?
Oh, meters per second.
Meters per second, right. Kind of like a speed, right?
Yeah.
Nice. So this gave us more information. We now have the initial velocity. I can even just put it up here. And now we want to know for part B, it's a little unorganized. We want to figure out the time.
We could just use number 1 because we have everything but T to
Exactly.
solve it.
Now the one thing is, do they want the amount of time it takes to go from the bottom to the top, or the total amount of time that they're in the air?
They just want how long they're in the air.
Right. So whenever we solve for the time, if we use V final equals 0, then we have to double that time. Because what we're finding is the time it takes them to go from the ground to the top of their jump. And so we double that time because it's going to take the same amount of time for them to go from the top of their jump back down to the ground. But I totally agree. So we're using V final equals V initial plus AT. What do I plug in for V final?
V final is 0.
V initial,
4.85.
and then I'm going to put minus 9.8. I could put plus negative 9.8, but that's the same thing. T. Go ahead and solve for T. Let me know what you get.
2,000 years later.
And you said we have to double our answer?
Yes, once we get the final time, we double it. Because the time that we're actually calculating from this equation is the time it takes to go from the bottom to the top. And we want from the bottom to the top, back to the bottom.
So my answer is 0.99 seconds.
Nice, that's what I got. Once I double my final 0.495.
Okay, that's what I got as well.
Awesome. So yeah, this is technically 1/2 T, and so I'm just gonna double it, and 0.99 seconds is the actual time that it's in the air in total. Awesome, good stuff.